Everyone. A couple things. We're going to have very interactive activity today, so get yourself set as if you're going to be taking a test. I'm going to flash some questions up and give you 1 minute to look over them. Maybe two, we'll see. But and we'll explain them as we go. But it's just kind of get that idea. Generally, we have about 17 questions on the test. I haven't gotten the test yet, but just about that. So I figure it's about, if you do the timing, 50 minutes, it's about 3 minutes per question. So part of the thing when we're learning math is learn to know it well enough so that you can just kind of go through. So what I've done is I've taken some, I've got the test bank from Cengage. So this is from, and you'll see they're very similar to the homework assignments. Some are multiple choice because they always give us a few of those, so we'll get some practice with those. Some are just, fill in the blank type things. But we're going to go through several questions. If you don't get all the way through it when sort of the working time, we'll explain them as well, and we'll keep moving, and we'll see if it might help by repetitively going through test type questions, if that'll help build some speed. You'll also have access to them afterwards if you want to use them as a secondary practice. I've got an answer key in there and stuff, so we're going to do that under the first class review, first in-class review here today. I also want to highlight the review resources. So these are additional, what's going on? Okay, I think we're okay. So far there's not that much there, but over the weekend, maybe later today, I will start posting some solution videos for each of the types of questions. There are some of them actually already in there under the calculator, how to use the calculator to solve them. So I did work through a few of them, both for matrix and probability method. So those are the two big topics that'll be on the test. Matrices, probability, they're kind of different from each other. So we're going to start today with the most recent stuff because that should hopefully be freshest. We'll come back over the weekend, give you the weekend to review back and go back maybe to matrix stuff, which was before spring break. And then we'll do a sort of similar review on Monday with practicing some tests. Remember, the exam itself has been moved up to Wednesday. And not to cause any stress to anyone, talk to me if you need to do it something different, okay? But I felt that was the best option we had with me being out of the, I'll be actually out of state, be over in San Francisco Thursday and Friday. Okay, so there's the department review, and that's a good one to do. I haven't touched any of that, so all the questions I have are from Cengage, and they're sort of fresh questions. And this is not to say that the ones we're going to work through are necessarily more likely to be on the test or not, but they're going to be helpful. If you understand the concepts behind this, you'll do just fine on the test. And I did choose a few of these review questions because they were different. So there's a PowerPoint in here or Google Slides, and you can go through them here. We're going to go through a few, and then there's an answer key. Notice there's a multiple choice. I put in, this is an active NumWorks calculator, so if you don't have one, you've got one here. You've got to kind of learn how to use it. But again, it's very important to know how to use your calculator because that's the technology we're going to use. That's how I've taught it. That's how we're going to do it. I've also got all the questions in a Word document. So if you wanted to do that, maybe print it out and work it differently, you could do that. There's a key to that. So those are all sort of resources there, additional resources to kind of help you practice with what we're going to do. So I'm going to go with a larger version. This is the same thing, but we'll just do it through the screen. So we're going to start with the counting and probability. So that was the week just before spring break. We did chapter 7 stuff. And I don't know if it's everything, but we'll start with 7.3 and 7.4. So certainly the last part. And what I did to pull up these questions, I looked at the exam review I have, since I don't have the exam itself, and I took similar questions, or or questions that were a little different but had the same concept. So I'm focusing on the concepts from the review because coordinators have, that's what they tell us, that's all you need. If you review that, you will be ready for the test. So that's what this is going to do. So what we'll do is I will flash up the question here. If you have your laptop and you want to sort of have a closer view, you could, from within Canvas, you could pull this up or take a look so it's easier to read, however you want to do it. I encourage you to work with the people next to you. And if you're not next to someone, you want to have someone to work with, get next to them. So this is sort of like a group thing. But I will sort of time it. We'll give it about a minute, or it's the first time I'll kind of look and see once everybody's kind of stopped, we'll then go talk about the question. We ready? Okay, so no points or anything, but just kind of try to build a little bit of speed. Let's see, where are we? Let me get my timer. Which is probably easier if I use this thing, right? Yeah, we'll just do this. Okay, so here's the first question. The experiment requires a sequence of 3 steps. The first step can result in 5 possible outcomes, the second in 2 possible outcomes, and the third in 6 possible outcomes. What is the total number of possible outcomes? You've got your choices there. Go ahead and work it. Come back in about 45 seconds and we'll do it together. Let's see if you can remember how to do this one. I better. Okay, let's stop there. Part of this is also I've studied foreign languages, Thai language primarily, and there's this app that I use that is helpful because it'll give you the word that you're supposed to say, the translation, and then the word, but it gives you a pause before so that your brain starts thinking. Not too much of a pause, and then you go into. So that's sort of this is. I just want you to start thinking about how to do this. So rather than focusing, so we got our answers. So one of those is correct, but how do we do this one? Is it the multiplication principle or is it the addition principle? Multiplication, because they're separate steps. So what are we multiplying? We're multiplying each step, right? 5 possible outcomes times 2 possible outcomes times 6 possible outcomes. It's simply 5 times 2 times 6, which is 30. 30 times 2 is 60. And I'll put that there. We'll come back and we'll look at this. The goal is that the next one's going to be fairly similar. So as you see this, oh, that's just all, we're just multiplying these three. You're going to see a very similar question and you're going to hopefully, again, to build some confidence here. Is that clear to everyone so far? So again, and I was a little nervous because I thought, oh, wait, do we add or we multiply? I was kind of, sometimes I forget, right? Okay, so we good to the next one? Okay, next question. I'll let you read and I'll stand back. Oh, it's a little different, but oh, Okay, we'll stop there. Again, just the idea is that hopefully you started to think, maybe you have a strategy, but I want to try to get us through many of these as we can. How many 8-letter sequences? Sequences, is that a permutation or a combination? Is order important with the sequence? 1, 2, as countdowns, 1, 2, 3, or 3, 2, 1. Countdown is 3, 2, 1. 1, 2, 3 is a count up. Sequence is, those are different things, right? So sequence order is important. That's the first thing. So when we do these ones, because again, you'll see in the review, there's 3 different questions, 3 different words. What we're looking for first is how many, are there any repeated letters? Because if I've got, in this case, 2 T's, right? Can I tell which T is which T? You can't, because T looks like a T. So there's 2 T's. There are 2 I's. And then everything else is different, right? So the way we go about doing this, thinking of a permutation, we're going to use all of these. We have to count how many there are. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters. So we're going to do a sequence of 8 letters. They might not all be words. But what we start with is these, when there's repeated, those, the order's not really important which T comes first, because we can't tell the difference. So that actually we use a combination. So what we do is out of the 8 letters, we're going to choose 2 of them. And those are the, we're kind of indicating that's the T's, and that will take care of how many ways that can be done. Then we're going to take care of the multiple I's, but since we've taken care of the T's, right, we've taken care of how many letters are left. 6. So out of the remaining 6, we're going to place the 2 I's with a combination, and this is multiplying. And then the last part, we're going to multiply by the remaining. So 6, I used up 2. How many are remaining? I've got 4 letters remaining. I'm going to use all of, oops, sorry, I did this when I was working on it. It's not a combination. This is a permutation, because they're all different. And I can tell the difference between a G and an S, hopefully. Maybe it was in first grade I couldn't, but now I can, okay? So I can tell those differences. So this is going to be the multiplication. Choose, permutation. And, oh, shoot, I didn't pull it up. Maybe there, again, hopefully you can go back to the videos on how to use the calculators. What did you come up with on this? Or if you didn't come up, could anyone put this in now? This times this times this. What do we get? I think you get E. So it's a pretty big number, right? Again, the permutations we could manually do. That's really 4 times 2 times, or 4 times 3 times 2 times 1. It's like 60. These things will come up with different numbers, but you can just enter it all into your calculator. And again, we've done some in the calculator videos. Or does anyone want to see that done with a calculator? Would it be helpful? Okay. Yeah, I think, and since I'm recording, people who aren't here, they can't offer it. So it might be helpful to actually see these. Oh, don't have my calculator up yet. So it's the other thing I forgot to do. And again, this is a good review, and you'll see what we're doing is question 18 has these many words to do. It's basically the same thing. And again, on the exam, I don't know if there'll be a multiple choice, which ones will be multiple choice, which ones won't, but we're doing a little bit of both. But the thing is we're focusing on how to do these. Oh, good, it came up. Okay, so we'll clear it out. It was 8, math, probability, the choice, and we were going to use 2 of them. That's for the T's. Remember, come over here and put a multiplication. So I think if you just put them next together, I don't think it works. It might, I don't know. But if it's not working, make sure you have a multiplication sign there. Probability, we're doing a choice. because order is not important on the two I's, but then order is important for the ones that we can distinguish. So we actually, well, I can do it this way. I'll go to a permutation, and that's going to be 4, choose 4. Now, we don't have to worry about turning it to a fraction, because remember, this is counting how many ways. We're going to do something similar with this when we get to probability, and then we're dividing, and we'll want that to be a fraction. But when we're just counting, it's very similar, but we're just going to come up with some big number, 10,080. Okay, so when it's multiple choice, it's kind of nice, because if you're way off, you're not going to match anything. Oh, I'm doing something wrong. So that's the beauty of where am I? That's the beauty. Oh, that's right. I think I have to go over here. Come on. There we go. Okay, so calculator gave us 1080. I think well, yeah, I'm going to stick this way. So far, so good. Okay, so words. We're going to do another one. Very similar, but a little different. Different word. How many ways can we arrange those letters? Just thinking what we just did. And again, remember, for those who came in a little late, this is all available in Canvas as either slides or in a Word document. It just kind of, you practice these a little bit. It's kind of what I, pick up some, not necessarily, not that speed in itself is important, but that you oh yeah, I know that. Whenever you learn a foreign language, one of the most important things to learn, how to ask where the bathroom is. That's what I've always felt. Here's the bathroom. If you go to Thailand, Hong Nam Yunai, where is the bathroom? Of course, you also have to understand the directions of how to get there, right? Liu Sai, Liu Kwa, turn left, turn right. So I can do that. That's some very important things when you're hanging out in a restaurant and stuff, and your friends leave you for a bit, and you got to use the restroom. You got to be able to ask. Important things. Okay, where are we? I didn't even time. What's that? Oh, okay, good. We're kind of getting. Okay, how do I do this? So again, how do we do this, and then what's an answer? How many letters? 1, 2, 3, 4, 5, 6. So count correctly. I think I also counted 5 the first time. So if you count wrong answers, and but the cool part is I was doing this, I think, with 5 letters. I wasn't matching anything. I said, oh, there's 6 letters, not 5. Are there any repeats? No. So this is a simple permutation. We're using all 6 letters. We're going to place all 6 as a permutation. We just plug this in the calculator, and what do we get? Is it 720? 6 times 5 times 4 times 3 times 2 times 1. Okay, so, but that's all that's going on here. If we had repeated letters, it's like that other one. But see, you'll get this question. Probably will be on there, something like this. Because again, you look at the review, there's a limit. Okay, so far so good? Again, this is a goal. And part of it's to kind of also reveal maybe what you want to work on a little bit. Remember, we'll go back to matrices, and I'll have some videos on those over the weekend, and I'll try to post them early. Okay, this one's a little different, but it's based on the same thing. I'll read it. My couch potato friend enjoys sitting in front of the TV and grabbing handfuls of 2 chocolates at random from his snack jar. Unbeknownst to him, I have replaced one of the 10 chocolates in his jar with a cashew, and he hates cashews. So there's 2 questions. How many possible outcomes are there the first time he grabs 2 chocolates? So he's going to grab 2 chocolates. How many possible outcomes are there? And then secondly, how many of these include the cashew? How many different combinations of things, right? Combinations. I just think this, and again, this is probability and combinations. It's either order is important, order is not important. We're using either combinations or This one's a little stretch. It also includes a sample space. Make sure you're counting everything. And remember, you can talk to each other too. Do look on your neighbor's paper. Okay, let's see if you at least developed a strategy. You might not have finished it. Some of you might be kind of, oh, what do I do, right? So let's just think of this. Friend reaches in. How many different things could happen? He could get 2 chocolates, right? So you got to count how many ways could he get 2 chocolates. I worked all these last night, but now they're not as fresh in my mind. What else could happen? He could get chocolate and a cashew. And again, order is not really important. This is like the marble questions that we're going to do a little bit later, but this is just counting. It's not probability. He could get a chocolate and a 1 cashew. Okay, and that's pretty much it, because there's only 1 cashew in there. There's 9. So then, how many ways could he do that? Well, he could get 2 chocolates. The way he would get 2 chocolates is, how many chocolates are in there? 9. And again, I did this wrong the first time. I thought 10, but I took 1 out and I replaced it with a cashew. So now there's only 9 chocolates. So what has to happen, out of the 9 chocolates, he has to choose 2 of them. Okay, so that's the number of ways that can happen, actually. Again, you maybe can't tell the difference, but we do have to count that. And then, what's the other thing that can happen? Out of the 9 chocolates, he gets how many? Just 1. And then out of the 1 cashew, he gets how many? Just the 1. So that's how we do this one. Can these both happen at the same time? No, because he's only reaching in, right? So this is where we add those 2. Okay, so this includes the addition rule in there. Okay, so if we do this, 9 choose 2. Let's see if I can. Let's keep. Actually, okay, maybe we'll just do it this way. Calculator. So we're going to have 9 math, choose 2, arrow up. I'm going to do the plus sign, so I can do this all on one line. You can do this individually as well, but this should work. Where did that 10 come from? I don't know. Let's replace it with the 1. Math. Oh, wait. Okay, we'll do this. I'll change the order. A 1 choose 1 times. Delete that. Is that? Oh, I can't. That's weird. And then we'll do a 9 math choose 1, which you'll see there's 9 ways to choose it. Really, the second one ends up being 9 ways. This, I can't remember what it ends up being, but we put it together. There's 45 different ways to do this. Okay, 45 different ways. Wait a minute. How many possible outcomes are there? So the possible outcomes when he goes in to do it is 45. How many of those include the cashews? So that would be just this. So maybe that's a reason why you might want to calculate them separately. But you'll see that 9 choose 1. There's 9 ways to do that. 1 choose 1. There's 1 way that comes up being 9. Okay, so the second answer is there's 9 ways that he would get the cashew. Is that pretty clear? Okay. And again, this doesn't ask for a probability, but if this was a probability, what would that be? What would be the probability that he gets the cashew? Probability of a cashew. And I'm just setting us up for the next set. It would be 9 out of 45. 45 is the total, which reduces down to 1/5. So 20% chance on the first time he gets it. 80% chance, right? So this gets us into the probability, which we're almost ready to dive into. So these, again, there might not be a question just like this, at least there wasn't in the review, but I chose it because it brings those concepts together. Okay, so far so good. We're going to do a similar one, but a multiple choice one of it. Oops, oh no, we're not. We're going to look at the answers. 45-9. So if you've been recording them, this is what we have, so we could check, go back. Ready for some probability? Let's see. Yeah, we got a few, so I want to get into these. We might skip around because I want to make sure, so I've got them divided. This is the first part of the probability. The last part is the marbles ones. I want to spend a little time because when I was doing this lesson, that part got cut off because my computer ran out of juice and then it didn't start recording again because I didn't reset it. So I want to do a few of those at least, so those are on there. Okay, so now we're into the starting of probability. The table below shows the frequency outcomes of 2 distinguished coins are tossed. It's a little bit different than what we've done, but there they are. The question is, what is the estimated probability that the second coin lands with heads up? So give 30 or 45 seconds, give it a try, see if you can at least get the setup. Remember, with all of these, we're probability, good things divided by total things. Good things divided by total things. So that's all you're looking for. Probability second coin lands with a heads up. Okay, so again, just get you started to think again, it's good over total. So first, how many total things are there? You could add all these together, or you could just, that's what I did. And, oh, they already told us it's 4,000. Okay, so they gave us the total. It was flipped 4,000 times. How many of those times is the second one a heads? Well, this one has a second one heads, so there's 1,200. This one has a tails second. This one has a head, so then there's 1,100. And I add and divide, right? So that's going to be 2,300 divided by 4,000. And round your answer to 4 decimal places. So this one, we don't have to worry about leaving it as a fraction. What did y'all get? 0.573? 575. Yeah, makes more sense. So about a 57.5% chance that the second one's ahead. Make sense? Okay, so focus on how we're doing it. I'm going to give you another one of these that's multiple choice. And again, you can go back, and what I would do is maybe later in the weekend, go back to come with where this feels fresh, and you can kind of see how you do. Because again, remember when you're taking the test to get it done in the 50 minutes, which we hope you can do, 3 minutes per question. You can do some of these. If you pick up speed, you might be able to, oh, I know exactly what to do. Boom, boom, you're done in 30 seconds, 15 seconds. Gives you more time for any longer ones, okay? So here's basically same question or similar question. Following table shows results of survey 440 authors. There they are. Compute the estimated probability of the event the author is a new author. An author is chosen at random. What's the probability that the author chosen is a new author? New author, established authors, totals. And again, and remember, you can pull this up on your computers too. It might be a little, some of these multiple choice ones are harder to read. I can. Okay, how many total authors? So total and total, both established and new authors. Authors just chosen at random, any of these. How many new authors are there? Doesn't even talk about successful or unsuccessful, but whether it doesn't matter. These are the new ones. All the new ones. And so then we can choose, you both divide both of these by 10, so 23 over 44, and that is one of the answers. Again, if you needed to reduce a fraction, let me just show that feature on the TI. You could do it easily enough. 230 divided by, what was it, 440? And then you go to your math. Oops, I can do it right here. Fraction. And it'll give you the reduced fraction. Okay, so, all right. I think this one's going to be similar. No, it's a little different each time. I wanted to get through. So a pair of dice is cast. And again, sometimes some of you, English is not your first language. To me, cast means to roll. So they do this and they use all these different English words. And sometimes I was even, what does it mean to cast dice? Oh, cast, throw, roll. Number that appears uppermost on each die is observed. Find the probability event that the sum of the numbers is 8. Remember, you've got to think back to how we could count this. 2 dice, sum is 8. And we've got the answers here, but you got to think. Yeah, something like this, I would guarantee you'll find a similar type question. There's going to be something about rolling 2 dice. So you got to remember that chart. How many different possibilities are there? 6 times 6, 36. So that's one hint. How many ways are there to roll an 8? Remember the diagonals. Remember the main diagonals rolling a 7. There's 6 ways to roll a 7. And then it gets smaller as it goes. So if I have 6 ways to roll a 7, how many ways to roll an 8? 5. Okay. Roll a 9, 4. Roll a 10, 3. So if you can think of it that way, you don't have to spend the time to reconstruct the whole chart. So if there's 5 ways to roll an 8, and there's 36 total ways, that's our probability. This does not reduce, and that answer is right here. Okay, so a lot of these, once you know, it's so easy. But remembering which one goes with which thing, that's the key with this whole probability. So I love probability and I hate probability at the same time, because it's also easy to confuse things depending upon how they ask it and to do the wrong thing. But then when it's explained, oh yeah, that makes perfect sense. Why did I get it? So far, so good? Okay. So I want to get over to the marble one. So a pair of dice is cast. This is another one. We'll just kind of do this one together. So what's the probability of the event? The sum of the numbers is 12. Same thing, right? How many totals are there? Well, there's one way to get a 12. Good. There's only, because you got to get 2 6s, right? So there's only one way to get a 12. How many different possibilities when you roll 2 dice? It's always 6 times 6, 36. See, this one's a little harder because it's not, you don't have the multiple choices, so you might, have to fill in the blank. Oh, my brain is blank. But, if I would have said 1 over 36, I might have just been able to pick it out in this case. But again, I don't know which ones are going to be multiple choice, which ones are going to be open answer, but that's it. Is there much work to show? Not really. I mean, you could construct the table, I guess, but you can also kind of, we do that enough, you can do that from memory. So far, so good? Good on that one? Okay. So again, counting, that's what I like about probability. Pair of dice is cast. So what is the sum of the numbers is 7. What's the probability that the sum of the numbers is 7? Very similar to what we did with 8, right? How many 7s can get rolled? 6. And you can count them, a 6 and a 1, a 2 and a 5, 5 and a 2, 4 and a 3. Yeah, there's 6. I lost count. But there's 6 out of 36. This one's what makes it hard is this is a reducing fraction, and you don't find the answer 6 out of 36 there. Maybe you get, distracted and think, oh, maybe it was 7 out of 36. No, it's 6 out of 36, which reduces down to 1/6. So you got to go here, okay? But again, look at that chart, but then analyze the chart and remember, okay, there are 6 7s. There's 1 less than there are, so 7 minus 1 is 6. And then the table, 8s are going to be 1 less than that. So that's 5, 4, 3, 2, 1, until I get to 12. And then it works, it's a symmetric on the other side. And then you go down to the casino and lose all your money because you play the craps. Craps is actually one of the games in the casino that actually had, that the player has a fairly high probability if you play it right. So it still favors a house, I'll tell you that, but it's one, if you play it right, you could come off with a slight win regularly. And I've known people who do that. They don't get greedy because you'll lose all your money that way. But you can, if you play it smartly, you can make a little bit each time, and then they just kind of bankroll that. But craps is one, if you play it right. You don't play all the side bets. That's where you lose your money. But you just bet the regular. I don't do it, but that's it. Okay. Okay. So here's some probabilities. Calculate theoretical probability, P of E, when N of S. Remember, S is the sample space, is 50, and the number in the event is 18. Again, very simple calculation, but you've got to, mainly I want you to see when they ask it this way, what are they asking? What is probability? Good things over total things. So give it your best shot. Really is a very simple answer, but the probability is so simple. Counting, they gave us the count, dividing, right? Bless you. but translating n of s, so 50 and 18. That's all we got. What do we do with those numbers? There's 18 possible outcomes that are favorable to us out of a total of 50 total outcomes. So again, you had this n of s, you had, what does that mean? Sample space. S for sample space. That's all the things that, there's 50 different things that could happen for whatever event we've got. 18 of them are counted as our event. 18 divided by 50. Not the other way around, right? Because it's got to be a number less than 1, bigger than 0. So that's our answer. And again, it probably reduces. It does reduce. So I just jump to my calculator. 18 divided by 50. And I go to my math key, my fraction, 9/25. Okay. And it may be a multiple choice one, or it could be like this. Okay. Let me just, next one, same type of thing. It's just multiple choice. So it's 6/20, right? Which reduces to 3/10. So that's going to be B. Okay, so you see, what I want to do is I want to get to at least a couple of the marble ones. This is using that formula. If you know the intersection, the union, and you can find the other ones. So those are there. And again, we've done a few of these. We can maybe come back to it, but practice with these, okay, and you'll get your answers. And again, there's multiple ones that I have here. We give you the intersection. Remember, I guess what we have to remember out of these ones is the probability of the union of two things is equal to the probability of each of them added together. But remember, when we do that, if there's any overlap, the overlap has been counted twice, so we subtract off that overlap. So the overlap is the intersection. And so we can use this formula, we can use the Venn diagrams, and I think this part was still in the video. We did go over this, so I'll let you do that, but I want to get in the recording some of the marble ones. Okay, so there's these. This is a very similar, it's very wordy, but I kind of wanted to throw one in there. It's just from the bank, and I asked this actually twice, 2 different ways. I'll do videos of these, but again, I want to and here's some answers. Wait, that last one, 55. I guess I missed that answer, so I'll get that in there. So I'll do a few of these also, so again, you can go back through, but I want to do at least a couple of these together with the bag of marbles, okay? Because we didn't get it recorded. So we want the probability. Okay. Find the probability that she has 2 yellow, 1 black, 1 green. Okay. So first thing we do with this is how many marbles do we have? We've got 4 red, 3 green, 3 yellow, 1 black. So we have to add them together. There's 7, 10, there's 11 marbles. And again, be careful, do it correctly, because that's usually, if I make a mistake, I make it right here, everything else is going to be wrong. So there's 11 marbles to choose from. So the first thing is, how many total choices are there? Well, out of 11 marbles, I'm going to choose how many? 4. So that's the important part. In the numerator, you're going to have a bunch of choices multiplied together, and the total chosen needs to add to 11, and the total here needs to be 4. So this is just going step by step. She has 2 yellow. Well, how many yellows are there? There are 3 yellows. So out of those 3, she is going to choose 2. Okay. She gets 1 black. How many black are there? There's 1 black, so she's going to choose 1 black. And then 1 green. How many greens are there? There's 3 greens. So out of the 3 greens, she's going to choose 1. And notice here, there's 3, 4, 5, 6, 7. I didn't add to 11. What am I missing? Well, this is, you could stop there, but what we could say is that out of the 4 red, she's going to get 0. Okay, that ends up being the number 1, and so if you don't put this here, you still get the same answer, but just to, if you're, all these should add to 11, and when I did this, I go, wait, I don't have 11 yet. Oh, right, she's not going to get any of the red. So you could kind of, they're all like this. And so this is a template. Everyone will work this way. But notice the amount that she chooses, 2 plus 1 is 3, 4 plus 0 is 4. She's only going to pick 4 of them out. So that's all there in this formula. When you do this, you get your answer. And again, since it's a fraction, they want it as a fraction. We use that fraction tool to do the combinations just like this. In fact, let me go ahead and finish this off because all the rest are exactly the same. Oops, get that off. See if I come over here. So I'm going to put a parentheses. Remember, there's a way to get a fraction template, alpha F1 if you want, but I'll do it without that. 2 and out of that she's going to choose 2. Wait, how many yellows were there? There was 3. Okay, thank you. So I'll come back and change that to 3, and out of the 3 she's going to choose 2, and then I have to times that by what was the next one? The black was 1 black. She's going to choose 1 black. Multiply it out of the 3 green. She's going to choose 1 green. And again, you could leave it off, but I'll just put it in here. You'll see it's out of the 4 red. She's going to choose 0 of them, which ends up being 1. One way to choose nothing. We're going to divide by the total, which was, there's 11 math. We're going to choose 4 of them. So that's the total ways to do it. And then we're going to go math, fraction, so that it gives us our answer as a fraction. Excuse me. Let's see. I need that up. No. I need to go up onto the line when I do that. So some of these, again, practice, practice, practice. Do this 3 out of 110. That's the probability. Okay. Each of these will be the same. It's just counting how many total marbles are there. That goes in the bottom. Certainly, certainly. And I'll be the one grading them. So if you aren't sure, put something. If it's a correct answer, I'll make sure you get the points. Because I prefer percentages myself. Although that's a very small percentage. So yeah, 3 out of 110, that's fine. WebAssign's very picky about that, though. They won't take anything but that. But again, on the test, if it's open response, you can put the decimal if you want. I'll have both answers. They'll both be correct. Okay, looking good. So remember, there's a few more questions in here. These are taken directly from that. It's good practice to try to do that, even if you just eyeball it, come back, but it'll give you into the method of taking the test. I'll do a few more of these, but I also want to leave some time on Monday for any open questions. But over the weekend, I will be posting solution videos to any of the reviews. So please do your best to work through that provided department review that they give us, which again will be similar to these, but we'll just we'll put it all together, and I'm hoping for very high scores this time from everybody, so we could do it. Awesome. Thank you.